Hello everyone, this is Dr. K. Jagannayaki, Associate Professor, MBA Department, Institute of Aeronautical Engineering, Dundigal. So today I am going to discuss about complex random sampling designs. See, sampling design is very essential whenever you are going to conduct any sort of research survey. So there will be two types of random sampling. One is simple random sampling, another one is complex random sampling. So in case of simple random sampling, it is very easy. By various methods, we can find out the samples from various universe or various populations. Here, there will be two types of sampling techniques. One is restricted sampling design, another one is unrestricted. So in case of unrestricted, so it depends upon the purpose of the investigator. Basing on that, he used to select a sample from various populations. But coming to restricted sampling design, so whatever designs available under this, they are complex in nature, where we used to consider both probability sampling techniques and non-probability sampling techniques together. So that type of sampling designs are known as complex random sampling designs. See, the complex random sampling designs, they represent the combination of both random and non-random sampling designs. So these sampling designs are also known as mixed sampling designs. So there are so many popular complex random samplings available. The first one is like systematic sampling, next cluster sampling, stratified sampling, area sampling, multi-stage sampling. In some cases, we used to consider the proportional size of the samples, and finally one more is like sequential sampling. So all these type of sampling designs, they are known as mixed sampling design. So let us discuss each in detail. The first one is like systematic sampling. Systematic sampling is that, see here, from a population, whenever you're going to select a particular unit from a population or a universe by using some number. For example, if the sampling is to select every ith item in a list. So for example, there are some 1000 items we have. So out of that, let us take, I want to select every fifth item in the list. So every fifth item, so first 5, then next 10, then 15, 20, like that. I used to select the units from the various universe. So that type of sampling is known as systematic sampling. Why? Because here we are following a systematic procedure to select a unit of a sample. So an element of randomness is introduced here by using random numbers to pick up the unit to which to start. So initially we have to decide whether I have to select the 5th item, 10th item, 12th item, like that. So these selections, it depends upon the random numbers. So basing on the random numbers, we used to start the first item from the unit. Okay, then next, once you decided this particular item, basing on that, we can easily pick out the remaining units from the sample. So this process is systematic sampling, and only the first unit we used to select randomly, but later on the remaining units whatever we have, that should be selected at fixed intervals. So systematic sampling has some advantages. Why we have to use this systematic sampling? So what are the uses of systematic sampling? So the systematic sample is spread more evenly over the entire population. For example, it is applicable when you have a large group of people. So from that, we need to select a few units as the sample. In that case, randomly we have to pick out any one person, and thereafter we used to follow at fixed intervals, like first, third person you have chosen in a line. The next third person will be the 6th person. Then comes 9th, like that. We used to follow a systematic criteria in this sampling. So that is the reason this sampling is known as a systematic sampling. And it is easier and less costlier method of sampling than other type of methods. Why it is easier? Initially, randomly you are picking one item. Thereafter, we used to follow whatever item initially you are going to select. Basing on that, we can easily pick out the other items in a sample. And comparatively, other methods like it is cheaper because here no need to invest much funds to collect the data to develop a sample. So it's very easiest and cheaper method. Then it can be conveniently used even in case of large populations. So whatever may be the size of the population, we can use very conveniently by picking out the random unit first. Then after that, other units we can easily pick out basing on that number which we have chosen at the first time. Apart from these advantages, this method is also having some sort of disadvantages. See here, if there is a hidden periodicity in the population, so this method is not an efficient method in case of hidden periodicity. Whereas some cases what happens, so already you are giving certain range, but we don't know how you are going to consider the intervals, time intervals and all. So during that time, it leads to some sort of inaccurate method. So you cannot apply in case of hidden periodicity of the population and all. So in practice, in real life, if you see the systematic sampling, whatever we are going to use, when list of population are available and they are of considerable length. So whatever population we have, we need to get the list of population. So from that, we can select a few units as samples by considering this method of a systematic sampling method. So otherwise, this method is not going to useful in all other cases. Then second type of complex sampling design is stratified sampling. See, under this method, the population is divided into several subpopulations. See, here the stratas. So we used to divide total population into different stratas. So every strata is one subpopulation. So this is N, and out of that I am going to divide into subpopulation or subgroups as N1, N2, N3. See, if we observe that each population that individually when you are going to consider they are of homogeneous, but when you are considering as a total they are heterogeneous. So the different subpopulations are called strata. So we select items from each stratum to constitute a sample. For example, the sample size of 1 as the population size you see. So 50 units in N1 and 35 units N2, 75 units like that. So the stratas may have different sizes. So from each strata, we used to select a few of the items and all together constitute a sample. Then stratified sampling results in more reliable and detailed information. See why? Because whatever samples I am going to select from different stratas, they will possess the same homogeneous characteristics of the total population. So this data is more reliable, and whatever information we try to extract from these populations, that will be accurate. See, at the time of selecting the stratified samples, we need to get some questions and we need to generate some sort of answers how to form strata. So people will have doubts whenever they are going with stratified sampling, how to select, how to formulate a strata. So strata be formed on the basis of common characteristics, because whatever way we are dividing the total population into subpopulations and each subpopulation is known as a strata. So there will be some common characteristics. So basing on that, we used to formulate the stratas. And all these stratas, whatever we are going to develop, they are purposively formed. There should be some purpose, some commonality. To achieve that common purpose, we used to divide the stratas. And these stratas, they are based on past experience and personal judgment of the researcher. So it depends on the researcher. So maybe his past experience, out of that, he will select different stratas, and from each strata, again, by taking some common parameters, he used to constitute a sample. Then second question is that how should items be selected from each stratum? So each stratum, again, we need to based on the simple random sampling technique only. Again, we need to select the items from the strata, and it can be used if considered more appropriate in certain situations. So in certain situations only we can use this particular technique. It is not feasible in all the types of solutions. The next one is how many items to be selected from each stratum, or how to allocate the sample size of each stratum. So the first step is just initially we have to formulate stratas. Then from each strata we need to collect some samples. Then after that, how many items should be selected from each stratum, or else how to allocate the sample size of each stratum. So as I told you, there will be variation in terms of stratas. In one strata, you may have more number of items, in other, we may have less. So how it happens? So the method of proportional allocation, under which the sizes of samples from a population of different stratas, they are kept proportional to the sizes of the strata. So for example, if you want a sample size of n, let us take a 30 units, that we have to draw from a population size of 9,000 units. So how do we do? Initially, we have to divide these 9,000 units into different stratas which possess different type of sizes. So basing on that, we allocate the sample units, how many units we need to keep in each strata. So this is a small criteria example for that. Here N1 is equal to N into P1. What is N1? Capital N1, it is the size of strata. N2, second strata size. N3, size of third strata. So like how we used to allocate the proportional allocation done on the basis of a particular criteria. So proportional allocation is considered, it is one of the most efficient and optimal design where the strata differ not only in size but also in terms of variability. So that is the reason this particular method, it is considered as reasonable to take larger samples. So if you have a large volume of data, then in that case we can easily go with stratified sampling. So more variable strata and smaller samples from less variable strata. So the variability also, it varies from the size of samples and the number of units. Basing on that, we can find variation in each strata. The next type of mixed sampling design is cluster sampling. So cluster sampling, in this case also, it is somewhat related to stratified sampling, but the basic difference is in case of cluster sampling, we used to divide the total population into a number of relatively small subdivisions. So there we used to say as stratas, the same population you are going to divide it into multiple subpopulations. Whereas in case of cluster sampling, the identical or homogeneous characteristics whichever samples will have, we used to form as different types of clusters. So these clusters, they are randomly selected for inclusion in the overall sample. So it reduces the cost. How it reduces the cost? By concentrating surveys in selected clusters. So it doesn't mean you have to carry out in all the clusters. So for example, if you want to carry out only in two, you can conduct your research study only up to that extent. So it is less precise than random sampling. A cluster sampling generally used because of economic advantage it possesses. See, it is very easy because as a cluster you are formulating and only few clusters you are going to study, as you are, from that only we are going to draw the sample inferences, and the same inferences you are going to consider as generalized statements as your conclusion of the study. Like how people they used to find solutions to various problems. Then it estimates whatever we used to estimate using these cluster samples, they are more reliable per unit cost. So every cluster you can able to analyze, and basing on that you can also have the reliability, we can check, and validity of the models whatever you are going to use in terms of statistical process. That is very easy in case of cluster sampling. The next one is area sampling. So like cluster sampling, here also we used to form different clusters, but it happens to be some geographical subdivisions. Basing on geographical area, we used to divide. For example, if you are going to study about a state, so in state, we used to have different districts, and districts, then further we used to divide into different locations based on the geographical region. So in that case, cluster sampling is better known as area sampling. So you are going to form the clusters basing on the area. So in Hyderabad, even we have different types of areas. Area wise, we used to form different clusters. So the cluster designs represents a cluster of units based on geographical area. So everything is same like a cluster sampling, but only the thing in case of cluster sampling, basing on some characteristics, we used to form the samples into different clusters, whereas here also the same process we used to adapt, but the only thing is it is based on the geographical region. That is the only difference between cluster sampling and area sampling. So the plus and minus points of cluster sampling are also applicable to area sampling. So whatever advantages and disadvantages we have discussed with in case of cluster sampling, the same advantages and disadvantages applicable to area sampling also. Then next type of sampling design is multi-stage sampling. As the name itself, it reveals that there will be more than one stages. See, in case of multi-stage sampling, it is like a further development of cluster sampling. For example, if we want to investigate the working efficiency of nationalized banks in India. So India, it is not possible because in India so many states are there. In every state so many districts. In those districts again we'll have different towns, then different colonies. Like that we used to divide into various subdivisions. So if you want to take a sample of few banks for this purpose, so what initially we used to do, first of all we have to select the large primary sample unit. So that is whichever is the largest branch in that particular state, that we have to take. This is the first stage of sampling. Then select certain districts and interview all banks in the chosen districts. So it is not possible to cover all the districts and all the banks. So that is the reason in a particular state you select few districts and you interact with the respective bank managers and collect some sort of information, whatever is related to your study. And after that, select randomly at all stages. When you are going with more than 2 stages, then that is known as multi-stage random sampling design. If you want to find out the working efficiency, we need to consider all these stages because alone India is not correct. So, if you want to know the working efficiency of all the banks or a particular national bank at country level, it is different. Then state level you have to consider. Under state we'll have different districts and all. Again in districts, again headquarters and some other areas in that. Then particular colony, particular institutions like that. We used to carry out the study further. Then coming to ordinary multi-stage sampling. So in case of big inquiries, so sometimes it is like extension of so many time it is going to one after the other we need to consider. There will be a lot of process involved in that. So in that considerable large geographical area, so if you want to study about a country, so individually what we have to do? From country to state, from state to districts to other locations like that we have to divide, and every stage we need to select some samples. That's how we used to conduct our study. Then what are the advantages of multi-stage sampling design? So multi-stage sampling design is very easier than the single stage designs. Why? Because in case of single stage design, the sampling frame whatever we are going to select, that is only in one single step we have to select. But whereas coming to multiple stage, one after the other, finally we used to refine an appropriate sample. That is possible only in case of multi-stage sampling. So we can develop into partial units. So a large number of units that can be sampled for a given cost under multi-stage sampling, because sequential clustering. So what do you mean by sequential clustering? So one after the other. So from nation, then state, then district, then other geographical regions. That's how we are going to select samples at every level. So we are following a systematic procedure. So in a sequential manner, one after the other. So where this is not possible in most of the sample designs, only in case of multi-stage we can have this facility, which is not in other type of sampling techniques. The next type of sampling is sampling with probability proportional to size. See here, it is also like complex as I told you, which involves both type of sampling methods. One is random sampling technique, another one is non-random sampling technique. So in case of cluster sampling units, they do not have same number. So if you observe, in clusters need not be the same size. It may vary. Some cases approximately they are same, but it is considered appropriate to use a random selection process. So whenever we are going to use random selection, it means that the probability of each cluster being included in the sample is proportional to the size of the cluster. So for example, if the size of the cluster 100 units and total population is 500 units, so 100 divided by 500, and your sample size if you want 30. So like how we used to calculate 30 by 5. So every case we need to have one sample in one cluster. The sample size is 6. Like that, it is always proportional to the size of the cluster. Basing on that, we used to have the sample units. So for this purpose, we have to list the number of elements in each cluster irrespective of the method of ordering the cluster. So whatever may be the order, but we need to consider only the number of elements irrespective of the order of the clusters. So whichever way you want, you can formulate your clusters. There is no systematic procedure in the formation of clusters. Then the results of this type of sampling are equivalent to those of a sample. It is based on random sample and the method is that it's not that much difficult to apply and is also relatively less expensive than other types of methods. Then the sampling design in case of sequential sampling. Again, it is also one type of mixed sample design and it is determined according to mathematical decision rules. So whatever information we use to submit as survey process progresses, everything is related to mathematical decisions. So in this case, the size of the sample is not fixed in advance. Like in previous time, we used to fix the size. Say I want only 30 as sample size or 50, 60 like that. But that may not be possible in case of sequential sampling. So it is applied in statistical quality control especially. And in case of when a particular lot, so it depends, sometimes we may accept or sometimes we may reject. So how can we go with acceptance and rejected decisions means it depends upon whether we have one sample, two samples or more than two. So it depends upon number of samples. So basing on the number of samples only, we used to accept and reject a particular lot. So in case of the decision test on the basis of more than two samples, but the number of samples is certain and decided in advance. So in that case, that type of sampling is known as multiple sampling. When you are going to study about only two samples, then it is known as double sampling. So in case of sequential sampling, one can take the samples one after the other as long as they can to do so. So it depends. If he want to desire further, he want to select again and again. He is going to repeatedly following the same sequential way selection. So it depends on the researcher. And if you go with such type of sequential samplings, up to a certain extent, we can reduce the systematic bias as well as the standard errors as well. So, at the end of the topic, after the discussion of all these things, the student or the learner can able to formulate how to use different complex random sampling and what is the mode of selection of the sample size. All these things you can able to understand very clearly. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.